Dear students, today's topic is reactions of naphthalene. The first reaction is oxidation reaction, which is simply the attachment of oxygens on the carbon. Let's take the example. The oxidation of naphthalene takes place in presence of oxidizing agent vanadium pentaoxide in presence of oxygen gas, and thus they are obtained phthalic anhydride. Here you may notice that the oxidation takes place on the alpha carbons, like this carbon and this carbon. That means the carbons which are directly linked with the benzene ring. The phthalic anhydride so obtained undergoes hydrolysis in presence of a base like sodium hydroxide and thus obtained phthalic acid. So you may infer that the oxidation of naphthalene directly leads to formation of phthalic acid. The next reaction is the oxidation of naphthalene in presence of alkaline potassium permanganate, that is KMnO4. In this condition, the oxidation leads to formation of phthalonic acid, which liberate a molecule of carbon dioxide, and thus it leads to formation of phthaldehydic acid. The condition is somewhat changed in the acidic condition. Naphthalene under acidic oxidation in presence of potassium permanganate leads to formation of phthalic acid. Let's move on to the next reaction, that is called as the reduction reaction. The reduction is the attachment of the hydrogens. Naphthalene on reduction in presence of hydrogen gas over a catalyst like nickel undergoes reduction of one of the aromatic ring, and thus it forms 1,2,3,4 tetrahydronaphthalene, which is commonly called as tetralene. The tetralene so obtained can further undergo reduction in presence of hydrogen at some elevated temperature like 200 degrees centigrade, and thus it converted to decahydronaphthalene, which is called as decalene. The next reaction is the electrophilic substitution reaction. So this is the first example of electrophilic substitution reaction. Naphthalene on reaction with nitric acid and in presence of sulfuric acid forms 1-nitronaphthalene. When naphthalene is reacted with bromine in presence of acetic acid, they are obtained 1-bromonaphthalene. The other reaction of naphthalene is its reaction with sulfuric acid in presence of a temperature like 160 degrees centigrade. At this condition, we obtained naphthalene 2-sulfonic acid. The sulfonyl group gets attached on the second position over the naphthalene ring. The next reaction is the reaction of naphthalene with acetyl chloride, that is CH3COCl, in presence of carbon disulfide. Dear students, in this reaction we obtained two products. The first one is this one where the acetyl group gets attached on the alpha carbon. The product so obtained is a ketone, and it is called as methyl 1-naphthyl ketone. The second product is the one where the acetyl group is attached on the second position or the beta position, and this product is called as methyl 2-naphthyl ketones. So these are some examples of electrophilic substitution reaction. Now let's see some special conditions. When the groups like chlorine, bromine, the methyl group, hydroxy group, the substituted amines and the amides are present at first position, the substitution is always homonuclear. That means electrophile gets attached on the same ring where these groups are already present, and the attachment takes place at position number 4 chiefly, and at minor level it takes place at second position. Let's see the example. For example, when 1-methyl naphthalene is treated with nitric acid and sulfuric acid, it undergoes nitration, that is attachment of nitro group, and the incoming electrophile, the nitronium ion, gets attached at position number 4. So here we can see that the incoming electrophile gets attached on the same ring. That's why it is called as the homonuclear electrophilic substitution reaction. Now let's see the second condition. When the chloro, bromo, methyl, the hydroxy, the substituted amine and the amide groups are present at second position, the substitution is once again homonuclear one, but now it takes place at position number 1. That is the alpha position of the naphthalene. Let's see the example. When we react naphthalene 2-ol with bromine in presence of acetic acid, the bromonium ion, that is the electrophile, gets attached on the position number 1, and thus we obtained 1-bromo-naphthalene 2-ol. Let's see the next condition. When the electron withdrawing groups like nitro, the SO3H, are present at position number 1, and if the group like chlorine and the amino group are present at position number 2, the substitution is always heteronuclear. That means the incoming electrophile gets attached on that ring where such groups are not present, and in this condition the substitution is always takes place at position number 5 or 8. Let's see the example. When 1-nitronaphthalene is reacted with nitric acid in presence of sulfuric acid, the naphthalene ring undergoes the nitration and the nitronium ion gets attached at position number 5 to give us 1,5-dinitronaphthalene. Dear students, the last reaction is called as the formylation reaction. That is the attachment of the formyl group. When naphthalene is treated with formaldehyde and hydrochloric acid, here we obtained 1-chloromethyl naphthalene, which on reaction with potassium cyanide gets converted to the cyanide derivative, which on further hydrolysis gets converted to the amide. So in this way we can see that the alkyl halide gets converted to the amide. So here we obtained 2-naphthalene 1-il acetamide. This amide, when undergoes acidic hydrolysis, the hydrolysis of this amide group takes place, and thus it gets converted to the corresponding acid. Here we obtain 2-naphthalene 1-il acetic acid. So dear student, that are the 4 important reactions of naphthalene. So thanks for watching this video. Please like, share and subscribe. Thank you.